number 5, find the following infinite limits. Okay, if you notice for number 5, all the x, okay, there's one-sided limit. 0 from left, 3 left, 4 from right, 1 from right, 6 from left, 7 from left. Okay, all one-sided limit. So substitute and get infinity sign. Okay, so now we're going to check whether it tends to negative infinity or positive infinity. So first thing for these questions, you have to direct substitute, then check. Okay, we're going to discuss number 5. Okay, number 5a, limit for the function 4 over x cubed as x approaches 0 from left. Substitute directly 4 over 0. 0 negative. Actually, this is not good to just write. To show you, this is negative. Okay, from left and power cube. Okay, odd power. So the answer suppose 4 over 0 equal to undefined infinity. Then since negative, power negative, and this is cube odd numbers, so the sign is negative. Okay, then just write 4 over 0 and is equal to negative infinity. Okay. Okay, 5b, limit this function negative 1, 3 minus x as x approaches 3 from left. Okay, substitute directly negative 1. Okay, 3, there is minus minus 3 from left. Okay, let's say if you do number line, okay, 3 is equal to 4, and from left here, okay, from here, okay, means at 2 point something, 2.99, almost 3, okay, but not achieve 3. So 3 minus something, same like 3 minus 2.99, get positive, right? Positive. So set positive, define. Okay, positive define. Then because of this one is set, since this one is set, so it produce positive. So negative equal to negative 1 over 0. Suppose the sign is positive. Positive. Why? Because of square root of set. Always give positive answer. So the answer is 1 over 0 is infinity, then negative. Okay. Okay. And if you take this one 3 on the right, means that 3.001, then substitute 3 minus 3.001. So this is negative. So negative is undefined. Okay, just for your info. Okay. 5c, limit 1 over x third x minus 4 as x approaches 4 from right. Okay, 4 from right. Then substitute. Okay, 4 minus 4. This 4 is from right. Okay, from right. This one is okay because of this one is just 4. Okay, not give any problem. And this one is 1 over 0. Okay, 1 over 0 means that this is always positive because of set always positive. It gives positive sign. And the answer is 1 over 0 is equal to infinity. So it tends to positive infinity. Okay. For number 5d, limit negative 1 over x minus 1 squared as x approaches 1 from right. Substitute negative 1, 1 minus 1, 0. Okay, then this one is from right. Actually, this is squared. Squared always give positive answer. Okay, so this one is negative 1 over 0. Actually, it gives the positive answer. Why? Because of square. Okay, even power. So the answer is this one 1 over 0 is infinity, then negative. Okay, because of this one negative. Okay, for 5e, limit to minus x over x minus 6 times x plus 2 as x approaches 6 from left. Substitute 2 minus 6. Okay, 6 minus 6 is plus 2. The problem is here. Okay, produce 0. 6 from left. Okay, this one is okay. Just substitute 6. Okay, so now the answer is confirmed. This one is negative 4. Below here is 0. Okay, 0. This one is 8. Okay, so 0, 6, less than 6. 5.99 minus 6. It will give negative. Okay, tends to negative. So 0 negative times 8, 0 negative. Okay, actually, can write this one. Okay, and this is not good. Just want to show you. Okay, just write infinity, negative, and this one negative. So positive infinity. Okay. For number 5f, limit this function as approaches negative 7 from left. Okay, substitute 2 over 7 minus 7. This 7 is negative. And then you get 2 over 0. And get infinity, right? Okay, positive infinity. Why? Because of absolute value. Always give positive infinity. Okay, so actually you can define first. And define first 7 plus x. So negative 7. 7 plus x is equal to 0. 0 x is equal to negative 7. So this is negative 7. So x plus 7 actually. To the right, that one is positive 7 plus x. To the left is negative 7 plus x. So here for this function, limit 2 over x approaches negative 7 from left. Negative 7 from left is this one. So from right. So we take the negative. Absolute value change to negative 7 plus x. Okay. Then substitute the value. 2 over negative 7 minus x. Okay, 7 minus 7 from left. And simplify. So here actually 7 from left is negative 7.001. Here negative 6. Here is negative 8. Okay, so substitute here this value. Assume this one is this value. More 7 minus 7.001 more than 7. So this one actually negative. Negative 2 over negative 0. This 0 is tends to negative. Why? Because of 7 minus 7.001. So this is 0 negative. Just negative. So 2 over 0 is equal to infinity. And then negative means that positive. Okay, settle. Okay, so for number 5 F. Okay, number 6, evaluate the following limits. Okay, A, if you check the x tends to infinite sign, positive infinity or negative infinity. Okay, and then when you substitute, get value or get a infinity. Okay, we try to check this. Discuss number 6. Okay, we try to find limit at infinity. Okay, for 6a, limit this function 1 over 1 minus x as x tends to positive infinity. First step, substitute. Okay, let's say you substitute. This is not good working actually. Just want to show you. Okay, is 1 over 1 minus infinity. Okay, 1 ringgit minus 1 million. Of course, answer is negative infinity, right? Okay, very big number. 1 over infinity, almost 0. This is 0. The answer is 0. Actually, don't have to show this. Don't have to show. And then let's skip this one and it's equal to 0. Okay. Number 6b. Substitute. First thing, substitute. And here is positive infinity. Okay. Positive infinity. Why? Because of, I show you this is not good solution. Just want to show you. Negative infinity plus 2. This is not good solution. And here is positive infinity over infinity. Positive infinity over negative infinity. We don't know which one. So this is actually not equal to 1. So we call this one is indeterminate form. Okay. And if indeterminate form, and check, oh, this is poly over poly. Okay, it tends to infinity. Poly over poly, you have to divide with the highest power of denominator. So, just you write the question. Limit x tends to negative infinity. Okay, you have to divide with the highest power of denominator. The highest power is x power 1. So, divide x. Okay, then so is simplify limit. Okay, x tends to negative infinity. This is x squared over x plus 4 over x over 1 plus 2 over x. Okay, then substitute infinity. This is negative infinity plus 4 over infinity is equal to 0. 1 plus 2 over infinity is equal to 0. Then this is negative infinity over 1. Okay, negative infinity over 1 or is equal to negative infinity. So you must skip this step. Okay. And that one is for 6b. Okay. For 6c, substitute directly. This one is infinity. This one also infinity. Positive or negative still under indeterminate form. If indeterminate form, check poly over poly. When poly over poly, you have to divide with the highest power of denominator. This is highest power. This is denominator. The highest power, the highest degree is this term. Okay, so we have to divide each single term by x squared. Okay. You also must skip this step. Just want to show you. Over x squared, x squared, x squared, x squared, x squared. Okay. So or skip up to you. Okay. And simplify. 1 over x over x squared, 1 over x minus 2 over x squared 1 plus 2 over x plus 1 over x squared. Then substitute 1 over infinity. Okay, 1 over infinity, that is equal to 0. Okay, just write 0. No need to show 1 over infinity. Minus 0. 2 over infinity also 0. Over 1 plus 2 over infinity 0. 1 over x infinity squared also 0, and 0 over 1 is equal to, okay, this one is for number 6c. Okay, here don't have to show this 1 over infinity minus 2 over infinity squared 1 plus 2 over infinity. Okay, and no need to show this class, just for you and imagine, just write this one. This one this and this. Okay, settle for number 6, C. For this one, first thing, substitute set infinity. Okay, substitute here, confirm infinity. X plus 3, negative. This one is negative infinity. This one also under indeterminate form. You cannot say this one is equal to negative 1. This is under indeterminate form. And this is third. Okay, third poly. So if third over poly or poly over third, so you have to divide this one each term by modulus x, or okay, for poly divide with the x, or third, okay, if x tends to negative infinity, divide with the negative third x squared. Okay, if x tends to positive infinity, divide with positive x squared. So here is negative infinity, so we choose this one, divide with the negative third x squared. Okay, continue. Limit x approaches negative infinity. X plus 3. So for this one, third, divide with the negative third x squared. For poly, divide by x. Okay. Okay, then simplify. Okay, still you have to write limit. Limit, this one s log s. This one got variable x. We have to write limit, Mr. Lim. So now, okay, bring here, just 5. Okay, over 1 plus 3 over x. Okay, simplify. Limit x tends to negative infinity. Negative 5 minus 2 over x squared, 1 plus 3 over x. Then substitute 5. This one is negative minus 2 over infinity is equal to 0. Okay. And 1 plus 3 over infinity is equal to 0. And simplify. Negative third 5 over 1 is equal to negative third 5. That one is for 6D. For 6E, limit 8x plus 1 over third x squared minus 9 as x tends to positive infinity. First is substitute this one, 8 infinity over third infinity, also infinity. This is considered indeterminate form, and check, oh, this is only over third. So in this case, if this one is tends to infinity and the negative positive, poly over third or third over poly. Okay, first thing is for poly function, okay, have to divide each term by x. Okay, for third function, if x tends to positive infinity, you have to divide with the third x squared. When x tends to negative infinity, divide by negative third x squared. Now here is positive infinity. Positive infinity, you have to divide by third x squared. Okay, is equal to limit 8x plus 1 third x squared minus 9. So divide by x. Why? Because of poly. And over third x squared. Positive, here is positive. If here is negative, here is negative. Same like number 6. Okay. So simplify. Okay, you have to write limit. Okay, this one. So 8 plus 1 over x. In here, so you get 1 minus 9 over x squared. Okay, x squared over x squared 1. 9 minus 9 over x squared. So just this is under 1 third. Okay, and simplify. Okay, substitute. value infinity, and answer is 8 plus 1 over infinity 0 over cert 1 minus 9 over infinity is 0. So 8 over 1 is equal to 8. Okay, for number 6E, answer is 8. For 6F, find limit for this one. So substitute. Here is cert. Cert confirm positive. Positive infinity. This one positive infinity. Okay. And okay. Plus plus negative infinity. So positive infinity minus infinity. This one you cannot say this is equal to 0. Why? Because we don't know which one greater. Okay, this one under indeterminate form. When under indeterminate form, because of this is just one line, not a ratio function, we don't know which one is part cert or poly. Just like times its conjugate. Its conjugate is special question. Okay, conjugate. So what is the conjugate for this one? Okay, then the conjugate is of course, okay, opposite this sign. So the conjugate is x cert x squared plus x plus 1 minus x over cert x squared plus x plus 1 minus x. Okay, then the conjugate. Then simplify. Limit x approaches negative infinity. For this one, conjugate. This one conjugate, and this one same like you use the concept of a plus b times a minus b is equal to a squared minus b squared, equal to use this concept. So this is x squared plus x plus 1 minus x squared over cert x squared plus x plus 1 minus x. Then simplify. X squared cancel. The answer is x plus 1 over x squared plus x plus 1 minus x. Okay, then substitute the value infinity, negative. This one is negative infinity on the numerator over infinity minus positive, minus plus infinity positive. So infinity over infinity also indeterminate form. Okay, means that check, this is function poly and this is cert. So when poly over cert, then you have to divide with the absolute value of x. Poly for poly function, divide with the x. For cert, okay, when x tends to negative infinity, you have to divide with the negative cert x squared. When x tends to positive infinity, divide by positive x squared. So this one is negative infinity. So negative infinity, you have to divide cert function by negative cert x squared. Okay, instead you need to continue. Okay, continue this one. Limit x approaches for negative infinity. X plus 1 divided by x squared plus x plus 1 minus x. So divide. For poly, divide by x over x. This is considered poly, x. And for cert negative, divide by negative cert x squared. Just remember that this one and this one negative, this one also negative. Okay, simplify. Limit x tends to negative infinity. This is 1 plus 1 over x. Okay, bring here negative. Okay, this is bring inside here x squared over x squared 1. X over x squared 1 over x plus 1 over x squared minus 1. Okay, minus 1. Then substitute 1 over negative infinity. So 1 plus 0, 1 over infinity 0, and negative third 1 plus 0 minus 1. So 1 over negative 1 here minus 1 is equal to 1 over negative 2 is equal to negative 1 over 2. So the answer is negative 1 over 2. Then for 6f. Number 7. This limit this function x at approaches p. Okay, p digit. Okay, and given this one is equal to something. So find the value of p. We're going to find value p. Okay, and then discuss number 7. Okay, first thing for number 7, substitute direct substitution. Okay, here is p. Okay, p here is constant. P is constant. X is variable. So now we need to substitute here into x. Okay, substitute p minus p over p times p squared minus p squared is equal to 0 over 0. This is indeterminate form. And check. This is third, and this is poly. Okay, so third over poly you can times conjugate, and then let's say times conjugate. Limit x equals p, third p minus third x, factorize x, p minus x, and its conjugate is third p plus third x over third p plus third x. Okay, simplify. Limit x equals p. This one. Okay, expand. Okay, one expand, and then gets p minus x. P minus x over is x. P minus x. Third p plus third x. So this one equal and cancel. Then is equal to limit x equals p 1 over x third p plus third x. Okay, and then make sure this one the value on the right hand side. This one. Okay, so after that just equate this value to on the right hand side. Okay, and then next is substitute p. Okay, 1 over p times third p plus third. Okay, this one is third p plus third p is 2 third p. Same like y plus y is equal to 2y. Okay, and then the next step is this limit on the left hand side is equal to 1 over 2 p third p, and on the right hand side is equal to 1 over 2 third 10. Okay, and then you can compare. Okay, this is 1 over 2, or simplify, better simplify. P third p is equal to third 10. This one, simplify. Because of 1 over 2 is equal to 10. Then next simplify p. P is power 1. P is power 1 times p power half is equal to 10 to the power half. Okay, then using the indices 1 plus 1 plus 2 is equal to 3 over 2. Okay, is equal to 10 1 over 2. I'm going to get rid of this power. Okay, and then we need to to both sides. Okay, 2 over 3. Okay, and then simplify this this one is cancelled. Okay, is equal to 1. Okay, and therefore P is equal to 10. Cancel this one. 1 over 3. Done. Okay, this one is one of the method times conjugate. Let's say you still have another method. Okay, that is okay, limit x which is p set p minus set x over factorize x p minus x. Then okay, x which is p set p minus set x over x. Factorize this one. Set p minus set x, set p plus set x. Okay, then because of this one equal, set p minus set x, set p minus x cancel. Then simplify, limit x equals p 1 over x, set p plus set x. Then substitute p, get 1 over p, set p plus set p, and then 1 over 2p set p. Then continue same like this. Continue. Okay. On the right hand side, 1 over 2 set 10, and continue until get this value. Okay, continue here. Continue. Okay, that one is now for number 7. Number 8. Okay, let this function x cubed minus 1 over x minus 1, find this limit. Okay, so this is fx using the function. This one also fx using the same function. X approaches 1, that is x approaches 0. For number 8, and you find this one separately. Find this one first. Second, find the second term first. Second, and then minus. Okay, let's say I'm going to find the first one. Okay, the first one, that is the yellow one. Okay, so it's limit x approaches 1, fx equal to x cubed minus 1 over x minus 1. Okay, then substitute value 1 minus 1 is equal to 0 over 1 minus 1 is equal to 0. So 0 over 0 is indeterminate form. Okay, when the indeterminate form, check, oh, this is poly over poly. Poly over poly, you have to factorize. Why? Because of x approaches value 1. Okay, and factorize limit x approaches 1, and one of the linear factor is confirm x minus 1. Okay, and x minus 1. So you're going to find the rest quadratic here. Okay, so using the long division or comparison. Let's say here is x cubed minus 1 this one is numerator. Numerator is equal to x minus 1, and the rest is a quadratic, a x squared plus bx plus c. Okay, comparison, compare to find a, b, c. Compare x cubed, that is 1. Okay, a. So a is equal to 1. Compare constant, this is negative 1. So constant negative c, therefore c is equal to 1. Then compare x squared, here is no x squared, 0. And then this one is produce x squared is b minus a. So a is equal to b, therefore b is equal to 1. You can double check. Let's say compare x1, x power 1. Here also no x power 1, 0. And here is x power 1. Here c minus b. So c is equal to c. Therefore b is equal to 1. Okay, so b is equal to 1. Then right here, x squared plus x plus 1. Okay, and don't have to write to factorize completely, no. Okay, as long as we get one linear factor, x minus 1, and can be cancelled. Okay, and limit x approaches 1. Okay, for this function, then substitute 1 plus 1 plus 1 is equal to 3. So settle for the first expression here, first term. Next, find the one. Okay, this one, limit x approaches 0, x cubed minus 1 over x minus 1. Substitute 0 minus 1 over 0 minus 1 is equal to 1. Better. Therefore, join the two, this one, limit fx as x approaches 1 minus limit fx as approaches 0. So, this one is equal to 3. Okay, it's equal to 3 minus the other one is equal to 1. So, minus 1. So, the answer is 2. Okay, so it's 2 for number 8. Okay, so actually how to determine one of the linear factor. Okay, here. Okay, actually the given is we use the given. This is clue. Clue to get one of the linear factor for x cubed minus 1. Either x minus 1 or 1 minus x. Just substitute. Let's say this is x minus 1. Substitute 1 into x cubed minus 1, get 0. To show this is a x minus 1 is a linear factor. Okay. Number 9. Given this function, okay, find limit fx as x approaches negative 3 minus limit fx, the same function, but x tends to positive infinity. Okay, we're going to discuss number 9. Number 9, limit fx x tends to negative infinity minus limit fx x tends to positive infinity. Okay, so we try do separately. We do this one first. Okay, do this one. It is limit x approaches negative 3 for the function 2x squared plus 5x minus 3 over x squared plus 3x. Okay, first thing, substitute directly. Substitute negative 3 to this function. So, 2 times 9 minus 15 minus 3 over 9, this one is minus 9. So, 18 minus 18, 0 over 0. This is considered indeterminate form. When indeterminate form, this is polynomial. So, for polynomial or polynomial, when x approaches value negative 3, so we have to factorize. Okay, continue factorize. Okay, we need to write limit. Okay, this one should be right. And then factorize and take x plus 3. And here is 2x x 3 1, and so is plus and minus. We check negative 1 times 3 negative 3, x minus 5x 6x minus x is equal to 5x. Okay, and check which one. Okay, this one equal x plus 3 cancel. So this one, okay, we can write this one is 2x minus 1 over x. Next step, substitute 2 negative 3 minus 1 over negative 3. So negative 7 over negative 3 is equal to 7 over 3. What is answer for the first part? So continue for the second part. Okay, let's say we write here. Okay, this is the part, the green color. And limit x tends to positive infinity. The function is 2x squared plus 5x minus 3 over x squared plus 3x. Substitute directly. So when substitute numerator at positive infinity, here also positive infinity. So this one consider indeterminate form. What is not equal to 1? Because we don't know which one bigger, right? So consider indeterminate form. We don't know the exact number, the exact value. So that is we can call indeterminate form. For polynomial over polynomial, this is poly. Therefore this one, if the x tends to negative infinity or infinity, you have to divide with the highest power of denominator. Okay. Limit x tends to positive infinity, just right, over x squared plus 3x. So this is x squared, the highest power of denominator. So divide each term with the highest power of denominator. So divide x squared. Then simplify. Limit x tends to positive infinity, 2 plus 5 over x minus 3 over x squared. So 1 plus 3 over x. Then substitute. Okay, substitute 2 plus 0 minus 0 over 1 plus 0. Equal to 2 over 1 is equal to. Okay, so now compare between the two. The two functions. This is limit x approaches negative 3. Value negative 3 is a value. That's why when you is indeterminate form. For the value, when poly over poly, you need to factorize. For this one, when poly over poly, then x tends to infinity. You need to divide with the highest power of the denominator. So you have to check the differences between this one. So for poly over poly, this one poly over poly, but the difference is only when x approaches value. X approaches something infinity. So continue. Limit fx, x approaches negative 3 minus limit fx, x tends to positive infinity. So this one answer is 7 over 3. 7 over 3 minus 2 is equal to 1 over 2. So the answer is 1 over 3. Then for number 9. Then given this function fx and gx, determine this limit fx over gx plus fx. X tends to positive infinity, x approaches value 2. That's number 10. Number 10, limit. This limit for the function fx over gx. Plus limit fx as x approaches 2. We do this one first. Second color. Then this one is limit x tends to positive infinity. Fx is equal to x cubed plus 2x plus 1 over 3x plus 2x plus 1. First thing, substitute directly. There is positive infinity over infinity. Indeterminate form. And check, this is polynomial over polynomial. Polynomial over polynomial. you have to divide with the highest power of denominator. Why? Because of this one is tends to infinity. Okay, next step. Okay, limit x tends to positive infinity. First step, x cubed plus 2x plus 1 over 3x squared plus 2x plus 1. Divide with the highest power is here this one. Just take x without 3. Okay, x squared over x squared over x squared, x squared, x squared over x squared. Then simplify. Okay, limit x tends to positive infinity. X cubed over x squared is equal to x plus 2 over x plus 1 over x squared. And then here is 3 plus 2 over x plus 1 over x squared. Okay, and then substitute the value. Here is x. So substitute that positive infinity. Let's say if you continue substitute, this one is equal to 0. 2 over infinity, 0. 1 over infinity also 0. 3 plus 0 plus 0. Actually, answer is positive infinity. Okay. For this one, okay, this part, limit x approaches to x cubed plus 2x plus 1. So substitute value to here. 2 cubed is 8 plus 2 times 2 4 plus 1 is equal to 13. Then combine limit x tends to positive infinity, fx over gx plus limit x approaches to for fx. Then this one is equal to, so is infinity positive. Okay, positive infinity. This one is 13. So 13 plus infinity, of course answer is infinity. Okay, that is answer for number 10. Number 11, given this piecewise function, find limit this one as y tends to 6. Okay, b, limit this one when y approaches negative 2. Here is actually domain negative 2. Okay, so transfer this piecewise to number line. We discuss number 11. For number 11, this piecewise function change to number line, and this is considered x value domain variable y, right? Okay, so here is negative 2. Okay, if you check here, y less than negative 2, less to the left, the function is y squared plus 5. When y more or equal negative 2, so right in the different level, and this function is 1 minus 3y. So now we're going to find limit when when y approaches 6. Check. Oh, 6 is this one is negative 3. To the right is the biggest number, 1. Okay, so 6 is here. 6. Okay, 6 is here. On the left, on the right, we are using the same function. That is, okay, limit 1 minus 3y as y approaches 6. Okay, and then we choose this one. Only one function on the one side 6. Y approaches 6. We don't have to find on the left and also on the right. Why? Because of this one is, okay, we take the same function. Then substitute 1 minus 3. Okay, 3 times 6, 18. So it's equal to negative 17. Okay, settle for part A. For part B, okay, since this one negative 2, okay, negative 2 here. At negative 2, you have two different functions. On the left, okay, on the left is this function. Okay. At the same time, on the right is this one, the same this function, 1 minus 3y. So in this case, we need to find limit as approaches negative 2 from left and also from right, and check whether there is equal value or not. If not, means that the limit does not exist, and otherwise. Okay. And okay, find limit x approaches negative 2 from left. Negative 2 left, function is y squared plus 5. Then substitute negative 2 squared plus 5. So this one is equal to 4 plus 5, 9. Okay, 9. And for this part on the right hand side, limit x approaches negative 2 from right. Negative 2 from right here. So this is the function is 1 minus 3y. 1 minus 3y. Then substitute 1 minus 3 times negative 2y. And then 6 plus 1, 7. So we're going to find this one. Okay, to find this limit. Okay, since limit gy x approaches negative 2 from left not equal to limit ey x approaches negative 2 from right. Therefore, limit gy x approaches negative 2 does not exist. Okay. So, on number 11.